Welcome. In this video, we'll be taking a look at how to graph a compound inequality. So there are two really important words in math, and they're quite different from one another, so we're going to explore what they mean. The first word is the word and the second word is the word or. So we're going to take a look at how we might use these in the English language, and then see if we can come up with a way to use the same words and define them in mathematics. So let's consider the following situation. Suppose that I'm interested in states, and what I want to do is gather all states where the first letter is an A and the last letter is an A. So in this first set, I'm only including states that have a first letter of an A and a last letter of an A. In the second set, I want to include all states that have first letter as an A or they have the last letter as an A. So let's consider a few states and see which category they would belong in. So the first state is Arizona. Okay, well, Arizona, its first letter is an A and its last letter is an A. It meets both conditions. Therefore, Arizona is going to go in this category. Let's see if it goes in this category. Is its first letter an A or its last letter an A? Well, actually, both conditions are met here, so we've actually met more than we need to. So that means Arizona is going to go in this set as well. Okay, let's take a look at another state. Suppose we have the state Georgia. Well, if I look to see if it's going to meet the requirements of the first set, its first letter would have to be an A, but its last letter would also have to be an A. And clearly, its last letter is an A, but its first letter is a G, so it's definitely not going to meet the requirements for this set. If I look over at this set, I'm going to put it in if its first letter is an A or its last letter is an A. Well, since its last letter is an A, it meets the second condition. So that means Georgia is going to belong over here. The next state is North Carolina. Well, again, since its first letter isn't an A, we can't put North Carolina in this set because this set only includes states where the first letter is an A and the last letter is an A. North Carolina, however, since its last letter is an A, is going to belong in this set because in order to belong to this set, you need to meet only one of these two conditions or both of them. So, since its last letter is an A, North Carolina goes over here. Okay, let's look at another one, Alabama. Well, this time again, the first and last letters are A's, so it meets both conditions. So Alabama is going to go in this set. And since both the first and last letters are an A, it meets the first condition over here, plus it meets the second condition, so it meets both. So that means Alabama is going to go in this set as well. So if you think about it, and is a lot more exclusive than or is. In order to belong to the and set, the states had to meet two conditions. They had to first have their first letter as an A, and then they also had to have their last letter as an A. So in mathematics, the word and means we're including only things that meet both conditions . Whereas the word or means that we're going to include things that meet, they don't have to meet both conditions. They can just meet one or the other or both. So or means we're going to include things that meet one condition or both. Okay, let's see how that might apply to problems 1 through 4. So in problems 1 through 4, we're supposed to graph the portion of the number line containing all points for which in number 1's case, x is greater than or equal to 6 and x is less than 7. So the first step in the process is to graph out each inequality separately. So what I'm going to do is I'm just going to put the numbers 6 and 7 on my number line. Okay, and I have to make sure that I put them in the right order. And if I graph the first one out, x is greater than or equal to 6, that's all of these numbers. If you didn't see how I graphed out an inequality, make sure you go back and take a look at that video to know why I'm using a closed circle here. And so if I look at what numbers are shaded on my number line, well, the numbers that are shaded are all the numbers that are 6 and bigger. So if I just do a little shading here, that's all of these numbers. If I graph the second inequality, x is less than 7, that means I'm graphing all numbers that are less than 7. So that's going to look like this. And if I shade my number line, that's going to mean that all of those numbers are shaded to the left of 7 on the number line. So now I need to look at the word and. And so remember that and means we're including only things, in this case numbers, that meet both conditions. Well, which numbers are both greater than or equal to 6 and less than 7 at the same time? Well, those are our middle numbers. So all the numbers between 6 and 7, the numbers that were double shaded, are going to be the numbers that meet both conditions of these two inequalities. So my answer is going to be only graphing the portion of the number line between 6 and 7, because those are, again, the only numbers that meet both conditions. So you can think of and as the double shaded portion of the number line. Okay, let's take a look at number 2. And I'm going to change it slightly so that instead of doing an and graph, we're going to do an or graph. And then instead of having x is less than or equal to 5, I'm going to change it to x is less than or equal to negative 5. So my steps are going to be the same. My first step is to graph out each inequality separately. So I'm going to graph out negative 5 and 2. Notice I'm not putting any other numbers on my number line. And if I graph out the numbers where that are greater than 2, that's all of those numbers. And so if I shade that, that's going to be all of the numbers to the right of 2 on the number line. So all of those. If I graph out my second inequality, those are all the numbers that are less than or equal to negative 5. So the shading would look like this. And now what I'm supposed to do, though, is to graph a set that combines these two using the word or. Well, what does or mean? Or means that I'm supposed to include things, in this case numbers, that meet one condition or both. So which numbers are greater than 2 or less than or equal to negative 5? Well, the numbers that are greater than 2 are exactly what I shaded over here. The numbers that are less than or equal to negative 5 are the ones that I shaded here. And there are really no numbers now that meet both conditions. So my final answer is to shade all the numbers, essentially, that I shaded here. So my final answer is going to be all the numbers less than or equal to negative 5 plus all the numbers that are greater than 2. Okay, I want you to try number 3 and 4. Pause the video and then restart when ready. Okay, so for number 3, if we want to graph all numbers less than 7, that's all of those. So that's all these numbers less than 7. All numbers greater than 8 are all the numbers to the right of 8 on the number line. So if I shade those. Okay, but now notice I'm supposed to combine the two sets using the word and, so I'm looking for the numbers that have been double shaded, the numbers that meet both conditions. Well, there are no numbers that are double shaded, so my answer here is the empty set. I wouldn't graph anything. So my final graph would just be blank. And finally, number 4, I graph out -4 and 2. All the numbers that are greater than or equal to -4 are going to be those. So if I shade the numbers on the number line, it's all of those. All the numbers that are less than or equal to 2 are all of those numbers. So if I shade my number line, it would be all of those. And now I'm supposed to combine the sets using the word and. So I'm looking now for the numbers that meet both conditions. And I see that all the numbers between -4 and 2 have been double shaded. So that is going to be my final answer. I'm going to include all the numbers from -4 to 2.